Again, no, good morning sa tanan. Okay.
Morning, sir.
How's my audio? Okay lang ba? Maklaro ra ba ninyo tanan?
Okay ra, sir.
Para ra sir.
Klaro na, sir.
Maklaro ra, no? So, this morning class, we will have a new topic, no? So, series parallel circuit, no? So, last meeting we discussed about katong KCL, KVL, and we have assignments on that, right? So, medyo ko ano, medyo ang among area no, medyo na namanday sa silingan pero I hope okay ra no. Klaro naman siguro.
Klaro na, sir. Klaro na.
Sige. So, kani if I write something palihog ko check no, double check if I write something no. Okay. So, if I write something no, makita ran niyo class no.
Kita ra sir.
Okay, great no. So, this morning again, series parallel no. So, unsa man ning series parallel no? So, ang series parallel class is that this is the typical series. So, meaning series ang series class, if you remember last time, the current no flowing in this circuit no, let's say it represented by letter I, is equal throughout the circuit. So meaning the current flowing on R1 is the same as the current flowing on the R2 no. That is series circuit no. While in parallel circuit class, the current flowing in R1 is different no from the current flowing in the R2 no. So meaning, but please also note that the voltage no across R1, this one, and across R2 is the same no, the same voltage crossing. Let's say if this is 5 volts, then R2 also has 5 volts. Here in R1, the voltage flowing in R1 is different from voltage flowing on R2 no, because in series class there's what we call voltage drop. Once the voltage crosses R1, there's what we call voltage drop no. So B equals to IR, diba? Remember IR. Okay? So that is the voltage drop across R1, and of course no, that would be deducted no from that voltage drop across R1, and then the voltage on that of R2 is the resultant voltage no. If for example we have source or independent source voltage no to power on that circuit. So in parallel class, the voltage across R1 and R2 in this schematic is the same, but the current no flowing on R1 and R2 are different. Okay, and basically if in this tawag ano, in this diagram, the I total across at this area is the resultant of I1, or what we call current flowing on R1 and current flowing on R2 no. So mo na itong bantayan no, the current flowing in the series circuit is the same, while in parallel is not the same, but the voltage across in parallel circuit is the same. So bali siya series, current ang the same, parallel voltage ang the same. Okay? So I hope it's clear for everybody no. Okay, so dunay questions on this slide? Wala?
Wala na, sir. Wala.
Okay, so, wala ra no. So for example, we have an example here no. So let's say we have this in slide 2 no, slide 3. So for example no, if we're tasked to what we call no, to to solve the equivalent circuit of R1 and R2 no. So just simple no. You just add R1 plus R2 no. R2, and that the resultant of that is the equivalent circuit no. So for example, if this is 1 and this is 2 ohms, okay, so the resultant is 3 ohms. As simple as that no. So may kag series imo na siyang i-add ra gyud na siya class no. So add. So for example in this circuit no, again, if let's say we have an arbitrary value of 1 and 2, and then you are tasked to solve the equivalent series, the equivalent resistance of the series circuit no. Just add 1 plus 2 equals 3 ohms. So that's it no, as simple as that. Okay, so questions on the series, equivalent series circuit? Wala. So sayon na kayo siya class, no? Series circuit. Okay. So slide number 4. Okay, so for example, no? So again, this is a series circuit, no? So we have this R1, we have this R2, no? Kanina, no? We have this R1, we have this R2, we just add that one, the equivalent circuit, no? So the voltage also crossing on this one, no? On this series circuit, for example, because we have voltage drop, no? In terms of IR, no? IR, no? Because we have here current, no? We have current here and we have resistance. So if we're going to add, no, the voltage drop, okay, across R1 and R2, the resultant of that is that the total voltages, no, crossing on that equivalent circuit. So kanina nagbutang tag arbitrary resistance 1 and 2, and then the equivalent of that, of course, 3, no, 3 ohms, no, and then the voltage across that one, if we're going to add, no, from the voltage drop crossing here and the voltage drop at R2, the equivalent of that, if we're going to total, is that that is that the total, no, voltage crossing on that resistance, no, R1 R2, no. Okay, so just add up the voltage drop across and that's it, no. If you're tasked to solve, no, R1 and R2, no, voltages on or voltage drop across R1 and R2. So inaana siya kasayon class. Okay. Sige, ako sa ni i-reason before we move on to the next slide. So please interrupt me, no, if you have questions, clarifications on the concepts that we discussed. So ibalik lang ako, no, sa R1 sa series class, no, if we're going to as a review ba, to get the equivalent circuit, the equivalent resistance, no, we just add up. Okay, and the voltage across R1 and R2 is different because of the voltage drop at the R1. For example, this if the voltage flowing, no, or the current flow at R1 to R2, so there's what we call voltage drop across R1. So the voltage drop across R1 and R2 is the total voltage, no, generated or supplied by the circuit, which is also in our representations as R equivalent is the same. So as discussed sa kaninga slide, no. So please also note that the current flowing on R1 and R2 is the same. So meaning the current I flowing here at R1 is the same current I flowing at the R2. Okay, so next to that is the parallel circuit, no. So parallel circuit din siya class, no. Parallel circuit. Okay, so nasayop lang din ko ano. So what is parallel circuit? Okay, ako lang Osborne.
The voltage is constant.
Okay, so what is parallel circuit? So parallel circuit, the arrangement of the parallel circuit is like this one, no? So the voltage across R1 and R2 is the same, is the voltage VAB, but the current on R1 and R2 is different. So the current on R1 and R2, if you're going to add that one, okay, in this, considering this one, but this is the same, is the I total, no? If this is the I total, this is the I total. So the current drawn in R1 is equal to the is, so let's say if this is IR2, so just add up this current and that would be the current here, okay, and the current here. And basically if you are going to get the equivalent circuit for our for the parallel circuit, that would be the I on this one. Okay, so unsa may formula how to solve the equivalent parallel circuit. Kanina in series we just add up the resistance, but in parallel it's different, no. So I will present it in the next slide na, no. Okay. Sorry. So in one class in series kanina, di ba? Yun ani ni R1 plus R2. In in ako ning kwan ha, na-discuss na nato ni. So, example sa siguro ta sa series, no? So, for example, in series, if we have this, if we are going to task, no? What is the equivalent circuit for for 10 ohms series to 20 ohms series to 30 ohms series to 10 ohms, just add up, no, as I've mentioned kanina, just add up. So we have, of course, no, we have 40 ohms, no, as simple as that, no. Okay. Eh, and then we have parallel circuit class. So something parallel circuit, no. So parallel circuit actually for this one class, for this example, medyo komplikado ang pag-solve sa equivalent circuit, no? So, equivalent circuit is we have this formula, no? So, formula, no? So, kani, no? We have this formula. So, asa man i-derive ang formula? Kani siya. So, this is the general formula. If we are going to simplify that one, di ba? Kani siya is the overall numerator and the overall denominator class, di ba? Ato man na siyang i-inverse, di ba? Katong magkwantag fraction ba, fraction divided by fraction, inverse nato. So meaning once we inverse this one, this R1 and R2 will become a numerator, a numerator that would become R1 R2 divided by R1 plus R2, no? So I will not discuss this one, no, because in high school gi-discuss na ni, no, but we have a general formula for this. So the question is, what if R1, R2 napag naka-series diri nga R3, no? Napag naka-series diri nga R3 for example, no? So we have a formula later that we're going to discuss. So for duha ka series resistance class R1 and R2 for example, no? Neglecting R3, no, in our example, in our case, no? What if kwan? We just timanan na gyud ninyo. R1 and R2 is the multiplication divided by the sum of R1 and R2, no? So later, no, we have an example for this one. Okay. So I will move to next slide. So this is the kanina, no? This is the ano, this is the what we call the discussion, no? So meaning no, this is the discussion kanina, no? Okay, so we'll move to another slide. So another slide na lang siguro to. Another slide. So the question kanina, as I asked, no? What if class is we have kato lagi, no? We have, what if we have this R here, no? Ani ba? Yan nga series. We have this. So this is R3 for example, and this is R4. So how we're going to solve that one? Nga kani nga formula is intended only for two resistance in parallel, no? So ang formula na class is 1 over R equivalent, okay, equals to 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over, let's say, infinite, no? Daghan, no? Rn, and so on. So, and so on, no? So that is the formula, no? This is the general formula, no? So for example, if you're going to solve only R, duha la ka R, no? You use this general formula, no? Actually, when you simplify this one class, it will lead to this simplified formula, no? Mas simplified din siya compared to this. This is the general formula, no? So let's say we have R1, R2, R3, and R4 parallel together, no? So you use the formula 1 over R equivalent equals to 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over R4 and so on. Okay? So that is the formula, no? So questions, clarifications on the derivations of the formula? So I guess not, no? So let's have some example, no? For the for the series no, parallel circuit. Okay? Okay, let's move on to the next slide. So for example here, okay? So sample problem, no? Let's say we have this what we call this one, three schematic diagram of a parallel circuit, no? So unsaon ganito ni? Unsa ganito yung formula ni? Class? So unsaon ganito ni?
Equivalent
R
is equal
equivalent
to
equivalent equals to
R1
katong simplified atong gamiton na lang R1
over
times R2
R1
R2
R1
over R1 plus R2, no? So what would be the answer for this one? Unsay answer ni number 1 using the formula?
1.
10 o 20. What is the equivalent? Dili na to ibutang.
Ano? Wait.
1? How about
Dinon.
others?
Dili sir. Wait.
Dili siguro 1.
Divide.
Dili 1, no?
10 sir.
So let's say we have this equivalent
10?
no.
300 over
Pila?
30. 300 over 30. Ohms man.
Dili 30 oy. 20 over 10 over 200 20 ra ni. Ohms man gud ni siya. Medyo basig dili klaro sa inyo, no? Ohms na siya, class, no? Dili na siya 100. Ang kanang last is ohms na
Ay,
siya.
okay.
Ohms na siya, no?
Ay.
Ohms na siya, no?
Okay.
Di maklaro sa inyo, ha?
6.66 sir.
Ohms ni siya, no?
6.66.
6.66. How about others?
No, sir. 6.67 sir. Round up man. 6.66.
Oh, pwede mo round up na lang, sir.
Ha?
67.
Yes.
Sige, round up to the nearest 2. Pila?
Kung i-round up, sir.
So the answer is 6.66, no? 6.6, 6.6, no? Or 6.7, no? So, as simple as, sa ganito na ito pag-solve, as simple as
By
10,
30.
di ba? Times 20.
20.
Okay, nya. Divided by 10 plus 20. Diba?
Okay, rounding up.
So, kani is 6.
Sir, round up sir
67, let's say 67 siguro.
5 sir.
Ohms. Okay, ohms, di ba?
Sir, round up sir
Okay, so how about number 2? Kani number 2?
5 sir.
10 og 10.
100, sir.
100.
So, 10, let's say 10 times 10, that is
5.
5.
100,
5 sir.
divided by 10, divided by 20. 5, di ba? Okay, no? So, how about number 3? Kani, number 3. Let's see, number 3 nato ni.
1 over R.
20 sir
So, saan ito general formula when more than
over
2? 1
equivalent.
Equal
let's say
to
1, di ba? 1 over R equivalent.
R1.
R
And
equivalent is equal to
20.
1 over pila man eh?
Plus
10
1 over 40.
plus 1 over 20 plus 1 over 40. So, unsa man eh?
1 over 60, sir.
70.
20.
20 sir
Ang kuwan.
70 1 over 70 sir
1 over 70 kung equals sa fraction,
Sige
sir.
daw.
20 sir 70
Or 70 na sir.
1 over 70 sir
Sige daw, sige daw. Ano na to, kuan, murag wala
Or
pa gyud ko kadungog
3
sa
over
correct
70,
answer.
sir.
Sige daw. What
3
others?
over 70.
7, or
3 over 70 kung i-total
3
pa
So
over
kani
din.
pila may
70, sir.
total ani siya tanan kani class? Pila may total ani? Kani pila may answer ani? Kani
23.3.
3 over 70.
so unsaon ganito ni pag-solve?
3, sir.
Unsaon ganito ni kinsa may makakuan gan unsaon
40 ang
ganito ni?
denominator.
Unsaon ganito ni?
40.
Katong LCD ba? Least common denominator. Adding fractions ba? Ha? Pila?
No, 40 divided by
40.
10 times 1.
40 ang denominator LCD.
4. Oh, 4.
So ganito 40 sa to 40 times
Yeah. 2.
No,
2.
40 divided by 10 times
okay.
1.
Pila man?
1. 2. Then times
4.
2. Then
Sunod plus
s plus 1.
Plus 1, sir.
2. 40
So,
divided by
7 over
20
over
times 1.
Then times 10
2
7.
s plus 1.
plus 1, di ba?
7 over 40.
So pila may total ani? Direta mag-start.
7 over 40.
So 6
Ako po,
over
nilis denominator.
dili 7 dai 7. Sorry. 7
7 over 40.
7
Ako po, nilis
over
Or equivalent.
40. 7 over 40. But
Transfer to
remember
another
nga, this
substitute,
is
sir.
1 over R eq pa ni. Equivalent, di ba? So, mo na ito paggawa sa R equivalent.
Transfer to another substitute.
Okay. Transfer to other side. Okay. Transfer to other
Yes,
side
sir.
and mabali ni siya class, di ba? So, kung ato ni siyang kaning R equivalent ako ni transfer to other side, that will become times, di ba?
Finding else.
Ani man ni, no? So, ato ning uliton ha, kaning ako ning reason ha, kani. Kuha naman ta ani, di ba? Simple man ni nga fraction, addition, di ba? Ako ning aditon, no? Sige. LCD atong gamit, no? So, di na ko mo discuss unsa ng LCD, no? Kay that would be our high school, no? Balik-balik kita sa una, no? So, ako ning ikuha ng
Bring up to 4
REQD,
over
no?
7.
REQD, equivalent. So, times na siya, class. Di ba? Equals to 1. So, kaning 4 over 7, ako sa ning ibalik dito sa pikas, di ba?
7 over 40.
4 over 7.
Dili dahil 7 over 40 dahil.
Ay,
Sana
equivalent.
ko nalibat naman ko. Okay.
1
7 over 40. So, unsa kaya ito? R equivalent equals to i-move na ko na other side. Sa may tabuan ni.
Oo, sir. Oh.
So, mahimo ni siyang denominator, di ba? Kung ako ni siyang i-move to other side class, mahimo na yung denominator, di ba? Kay times man eh, di man ni addition nga atong i-minus. Di ba? Mahimo na siyang denominator, di ba? 7 over 40. Kaning 1 over 1 all over, ang tawag na ba? All over 7 over 40 class 1 ko na simplify is actually that is equal to 40 over 7. Diba? Sakto ba? 40 over 7?
Yes, sir. Oh, may kakuan.
Diba? So nganong nawahimong 40 over 7? Ang 1 all over 7 over 40 nahimong 40 over 7? Nay mga tanang anong naingon ana? Di ba 1? Di ba 1 all over
Cross multiplication.
40 over 7, di ba?
Yes. Cross multiplication.
Kaning 1 plus
Multiplication tawag anak.
kung ako ni siyang ikuan, di ba mahimo man ni siyang kuan ka partner, di ba? Ang ana man ni siya.
Yes.
1 over 1 times ako ni siyang mahimo ni siyang 7 over 40.
Cross multiplication.
Oh. Naka-remember mo ani sa katong adding of fractions?
71.
Multiplication of fractions nga whole
71.
number divided by fraction, di ba? Ato nang i-inverse niya, i-cross multiply kay gi-understood ba nato nga
Yes, sir.
kaning 1
Yes, sir.
ang kwan na ni is
Yes,
1,
sir.
di ba?
Opo.
Murag ang 1 bagi assume nato, so cross multiply, so 1 times 40 nya 1 times 7, that is same equal to 7 over 4. Ang answer is
71.
5.71 ohms. But the question is, what if we have
Sige.
so na 40 and ngano nahimong 5.71? What ano?
Yes, sir.
At yun
So,
tatlo.
what if class na ani siya kani siyang duha, let's say ato ning giparallel, no, kani ba? So ato ning giparallel siya, no, atong giparallel, no. So 10, 20, 10, 20, 40 giparallel na nato siya, no. So pwede sa ninyo kuanon kanang unahon ning duha, ana ba? Unahon na po ni nato ning duha. So ang mahitabo ani, ako ni i-reason class ha. Anyway, our lecture man is recorded, no. So walay problema, no.
At yun tatlo.
So for example, no, pwede sa nimo iparallel ning duha, and then we have this resultant na ana, no. Nya kani sad siya mo ni ang iyang resultant. Nya kani sad siya parallel na po namon ning duha. Usa-usahon nimo ba? Mo na sad niyang resultant. Nya dayon ang last is katong 40 ohms. 40 ohms. So pwede sa ingon ana. But if you have a calculator class, no, labi na ang kuan man gud ana is karon ang calculator na magud karon, di ba? Sa una kay kinahanglan kita palit og scientific calculator, no? Pero karon siya class, ang calculator app na siya, no? App. So makakita mo sa inyong calculator, anaon na ninyo siya pag kuan class, no? Makakita kinsa may mga nag-download scientific calculator, makakita mo x nya to the 1 kana sa calculator. So inyong buhaton is that, for example, 10 nya inverse may tawag ana class. 10 inverse plus kani ba? Plus 20 nya inverse na sad, pinduton yung inverse for 20. Kani yung pinduton. And then plus 40 inverse, okay? Inverse na nimo kay meaning inverse nimo is 1 over 10 plus 1 over 40, 20 ba? And plus 1 over 40. So mo na yung pasabot inverse. So equals ka.
Isip na
So you have the answer of 7 and 4.
Ay,
Yung
isip
answer
na.
na class is
Kung napay ka, kanan
7 over 40. But remember class, ang equivalent pagod ani is 1 over, di ba, R? Di ba? Equivalent. So imo na sad siyang i-inverse para makakuha kag equivalent. Ang answer na imo na sang inverse. And then you come up with 5.71. So the same technique that you're going to do if halimbawa kato akong example nakaparallel ni silang 5.
Naisip ka?
Oh.
Kung napay ka, kanan
Sige, no? So, nakuha ninyo. If you have scientific calculator na i-download sa inyong mga cellphone, you can try this later, no? After our discussion na siguro, no? Because some of you may using your cellphone to listen this discussion. So, in ana na siya class, no? So, ana ka sayon, no? If you have scientific calculator. So, I'll erase this one and move to another example siguro. So nakuha na nato, no? Natay questions, clarifications. Actually, ang series dali ra gayo, ang parallel ay medyo medyo kote, no? Because we're dealing with fractions, no? So in summary class, no? Series the how to get the equivalent circuit of a series is we just add up the series, no? So meaning natay summation of RK, no? So for example, 10 ohms, 20 ohms, 30 ohms in series. But in parallel class, this is the general formula for parallel. So kani siya class ako na siyang i-expound is that mo ni siya. R, R1, nya, plus 1 over R2, and kung ano, plus, so on, no? So on, Rn, no? So, kung pila man na siya, 5, so Rn, Rn. So, kung duha lang siya, class, pwede na gini siyang simplified formula, no? Kung duha. But again, so, para nang di mo malimot, no? I-memorize ninyo ning general formula because even this one class, kani siya, sulayan ninyo ni, kani nga 1 over R1 plus 1 over R2, na R1, R2 is just the same, no? Answer, no? Using this formula, kani nga formula. Parihar gid sila, no? So, please note sa class na there are instances nga we have short circuit, no? So, the R equivalent for a short circuit is 0. No? 0 na siya, class, basta short circuit. So, the same with the concept katong atong mga discussion previously. So, mao ni siya inyong timan-an gyud as a summary of the discussions kanina nga ang series dali ra gyud kayo, no? Ang iyahang resistance imo lang i-add, but in parallel it is an inverse, the summation of the inverse of its resistance. And then in series, class, along the circuit the current is the same, but in parallel what is the same is the voltage, no, across its parallel parallel node, no. So na siya the same voltage, no. So in series, in parallel, okay, in series it's different, no, because of the voltage drop. Okay, so I think, no, for you to understand more, we will discuss more example, no. And after that one, so for the rest of the time, I'll be giving you activity exercise. Okay? Para ma-practice kita, no. Sige, no. So pila man akong i-prepare nga. Okay, so daghan gani siya, class, no. So kaning duha tong solbon niya. The remaining two will be your activity exercise, no. So kani, no, example, given to resistance R1 10 ohms, R2 20 ohms connected in series, what is the total resistance configuration? So if I'm going to draw this one, so sayo na gyud kay, no,
Yes,
we have this circuit, no, and then we have this circuit, and then this is
Hello.
R1 and this is R2. Okay, so this is 10 ohms daw ni siya, class, and this is 20 ohms. So find the equivalent resistance. Okay, so equivalent resistance daw. So this is plus na nimo 30 ohms. As simple as that, no? Because this is connected in series. Okay? This is connected in series. Okay? So, what is that? So, klaro na kayo, no? Sayon na kayo, class, no? So, next problem. Anyway, class, for your activity exercises, I'll be giving hint naman, no? Para makakuha gid ang tanan, no? At least guided ta ba, no? So, for example, here, in second example, given two resistor, R1, 40 ohms, R2, 100 ohms, what is the equivalent resistance in parallel combination of this resistor, no? So, sayon na kayo, no? If we're going to draw this one, so, yan ana ra ni siya, no? And then, we have this, another resistor.
R1 times
R1 times R2
So, parallel siya, no?
over R1
So, this is 40
times R2
ohms. And this
Over
is
R1
over
100 ohms.
R1 plus R2.
So, the question is, what is the
28.57,
equivalent
sir.
R equivalent, no? Okay,
40, sir.
equivalent, no? Equals to question mark.
40
Unsa kay
times
formula ani, class? Katong
40,
duha ra ka buok siguro.
4,000.
4,000.
R equivalent equals to
40.
10 angkos, sir.
R1 times
R1 times
R1.
4,000
Okay, so
divided
R1
by
R1 times
28.56.
R2.
R2
Okay.
over
All over
R1 plus R2.
R1 plus R2, no? What is the answer, man?
28.57, sir.
Okay, so atong check, no? So 40 times 100,
4,000.
4,000 divided by 40 plus 100, 140.
4,000 divided by
28.57, no? 28.57. So the answer is 28.57. Let's say, kuan lang, no? 2 digit lang, for example, ohms. So that this is the equivalent circuit, equivalent resistance, no? For these two parallel resistance with a value of 40 ohms and 100 ohms. Okay? So, very simple, no? Very easy, no? Just like eating peanuts, siguro, no? Very easy, no? So, the next two, the last
Yes, yes.
two slides class would be your activity exercises, no? Ako ni siyang ibutang sa, ano? Ibutang sa kanang unsa tawag gani? Ako ni siyang ibutang sa assignment tab para ang inyong answer dito lang po niyo i-submit, no? So, in this activity exercise number 1, so given 3 resistor, no? R1 which is 10 ohms. 10 ohms ni klasa kani nga symbol ba? Ohms niya, omega ohms. Do not
Yes,
confuse this one, no? So this is the unit for resistance, no? Nya R2 is 20 ohms and R3 is 1,000 ohms, no? Connected in parallel. Okay, medyo lisod-lisod, no? So connected in parallel, so what would be the equivalent circuit schematic diagram for that is we have this R1
Yes, sir.
and then we have this R2 and we have this R3, no? So connected na in parallel. So you are asked to solve, okay, the equivalent resistance, R equivalent. Okay. This is the unknown, okay? So what is this one? 10, di ba? 10 ohms. This one is 20 ohms. And this one is 1,000 ohms. Okay? So, very easy, no?
Yes, sir.
So, very easy, no? So, sayo na kayo, no? So, and then, for the next item,
Si Ray,
next item, okay, next item,
Ruan.
so this is the second, no? So, determine the R such that the circuit in figure A, so kani A, is equivalent to
Yan
circuit
lang, sir.
figure B, no? Enter the value of the box below without, so walay box, no? Kaya ako
Ay,
rin
sayon
kopya,
na
no?
ni sir kay kuan
So,
same raman.
enter the,
I-class
so,
na, sir.
imong kuano, no? Ako lang i-delete, no? Para di ta ma-confuse. So, the same class, no? Asa may sayon katong number 1, number 2. Let's say if this is number 1 and this is number 2. Asa may sayon?
Ruan.
Number 2, no? Number 2, no?
Connected.
So, determine the value of R such that the circuit in figure A, this is figure A class,
Ay, sayon na ni sir kay
is equivalent to figure B. This is figure B.
I-class na, sir.
So, what is the, ang ipangita gin niya is R equivalent ra gid niya, di ba? And note that these are connected in series, no? Ay mo ka-confuse aning 4, niliko lang ni siya, but imong tan-aon, wire ni siya nga gi-bend, di ba? Series ra gyapon na siya, no? Just the same as kwan, di ba?
Okay, sir.
So lahim gitong parallel class kay kwan man gito kanang duha man gito kabog nagparallel, di ba? Kani naka-series na kani balik ba na sila, di ba? Tan-aon nimo usar na sa ka-loop, di ba? No, usar na ka kwan, continue. So this would be your activity exercise. So do this in kuan until 10:30 man ta, no? So ang kuan siguro ani ang deadline is karon so adlaw, no? 11:59 PM. Okay ra ninyo, no? Sayon naman kayo ni siya class. Sayon na kayo ni, no? So in a moment, no? I'll be kanang uploading this in our MS Teams as in the assignment tab, but this is activity exercise, no? Murag activity exercise
The number 6 na, sir.
Check with
Punto
our
nila.
records,
Pabayad
no? So that would be the end of our theoretical discussion. For the rest of the time, you will do activity exercise, this activity exercise under series and parallel circuit for the rest until the rest of the time, no? 10:30, no, but I'll give you enough time to answer this one until 11:59 p.m. today. So I hope kanang fair na sa inyo ha.
Direct.
Number 6 na, sir.
Punto nila.
Okay, number 6 na ni, no? So number 6 na daw ni, no? So